Hello students, in the previous video we discussed about properties of Z transform, and we took some examples on the properties of Z transform. That means using Z transforms, how using Z transform properties, how we can obtain the Z transform of a given signal. So the steps will be reduced compared to the uh, natural method that will start with the definition of Z transform if you use the properties of it. Now here is a different example. In this one, x of n, its Z transform is given for a signal x of n, which is z divided by z square plus 4, and its ROC is also mentioned with ROC is less than 2. So ROC will be less than 2, means we will be having a circle with radius 2, and ROC will be inside that circle. That is the meaning. Now, using Z transform properties, we have to determine the Z transform of these two signals, given y1 of n is equal to 2 to the power of n into x of n, and y2 of n is equal to n into x of n. So we'll start with the first one. So y1 of n is equal to 2 to the power of n into x of n. So we are trying to find out y1 of z here. Now given x of z is equal to z divided by z square plus 4. Now if you look at the input, now it is in the form of alpha n into x of n. Now if you go back to the properties of Z transform, it is resemblance to scaling property. Now the scaling property says if you have a signal like alpha n into x of n, then its Z transform will be x of z by alpha, where z by alpha is less than 1. So this is the meaning. Now if you look at the signal, we have 2 to the power of n into x of n. That means in place of alpha we have 2 here. So that means all you have to do is to get y1 of z, you have to replace x of z with x of z by alpha. In this case alpha is 2, that means x of z by 2. So if you replace z with z by 2 in x of z, you will get the Z transform of y1 of z. So that is the solution for this. So let's take that. Using scaling property of Z transform. So using scaling property, we can write y1 of z is equal to x of z by 2. Why I have written 2? Because in place of alpha we have 2 here. Therefore x of z by 2 is equal to, now replace this z here with z by 2, and to make that step simple, I am going to write it in this way: xz divided by z square plus 4, where z is replaced by z by 2. Now if you replace this, you will get z by 2 divided by z by 2 whole square plus 4. So that will give you the answer as z by 2 divided by z square by 4 plus 4. Now if you go for the simplification, you can take this 4 as the LCM. That gives you z square plus 16 divided by 4, so which allows us z by 2 into 4 divided by z square plus 16. These to get cancelled, so you will remain with 2z divided by z square plus 16. So this is y1 of z. Next, coming to the second one, so we have y2 of n is equal to n into x of n. Now this is simple. It is just the differentiation property. You can directly apply that. So the differentiation property says n into x of n. If you perform Z transform, you will get minus z differentiation of x of z with respect to z here. So using differentiation property, so we can write y2 of z is equal to minus z differentiation of x of z with respect to z here. So minus z differentiation of z divided by z square plus 4 with respect to z. Now if you perform this differentiation and if you simplify, you should get z cube minus 4z divided by z square plus 4 whole square, and the z transform is less than 2, which is given, that is ROC. So this is y2 of z. So I'm not going for the detailed simplification of this. So just try this one and you should get this answer, z cube minus 4z divided by z square plus 4 whole square. That means you have to apply u by v form of differentiation. So you should get this, that is the quotient rule. You will get this answer. And coming to the next problem, here we have given determine the z transform of the following signals and sketch the ROC. Now what is the given problem? In the first one, x1 of n is equal to 1 by 3 n, where n is greater than or equal to 0, and it is 1 by 2 to the power of minus n for n less than 0. Now the second one, or second signal, is x2 of n is equal to x1 of n plus 4. Now observe this, x1 of n has a signal for two different time limits. Now x2 of n is equal to x1 of n plus 4, that is x2 of n is the time shifted version of x1 of n. So that you have to remember. Now let's start solving this. From the definition of Z transform, we have, since I'm finding this first one, I'll write this as x1 of z summation n varying from minus infinity to plus infinity x1 of n z to the power of minus n. Now x1 of n has two different values at two different levels. Now for n less than 0, it is 1 by 2 to the power of minus n, and for n greater than or equal to 0, it is 1 by 3 to the power of n. So that allows us to take the limit as n is equal to minus infinity to minus 1. So this is the negative part of n, which will be 1 by 2 to the power of minus n z to the power of minus n, plus n is equal to 0 to infinity 1 by 3 to the power of n z to the power of minus n. And if you see these have common powers, so we can combine them. So n is equal to minus infinity to minus 1, 1 by 2 z to the power of minus n, and this one is n is equal to 0 to infinity, and we have two different things here. So I will take 1 by 3 z inverse whole to the power of n, because I'm trying to bring this to a standard geometric series form so that I can apply that. Now this one you can see the limit 0 to infinity a to the power of n. This is in the form. Now this one we have minus n here, and if you observe, the limit is from minus infinity to minus 1. Now if I change that limit from n is equal to 1 to infinity, then it will be 1 by 2 z to the power of n, and the next term will be 0 to infinity 1 by 3 z inverse to the power of n. So that's call this as 1, because to get ROE, these two sums, they must converge. Okay, so that we'll use at the end after finding x1 of z here. Now from the geometric series, if we have limit 1 to infinity a to the power of n, that is given by a divided by 1 minus a, and if we have the limit from n is equal to 0 to infinity, then it is 1 divided by 1 minus a, in which case both a is less than 1. Now applying this, in place of a we have 1 by 2 into z in the first term. In the second term we have 1 by 3 z inverse. So using that, you can write x1 of z is equal to 1 by 2 into z divided by 1 minus 1 by 2 into z plus 1 divided by 1 minus 1 by 3 z inverse. Now if you take the LCM of these two, so you will get 1 by 2 z into 1 minus 1 by 3 z inverse plus 1 minus 1 by 2 into z here. Now if you continue further, you will get 1 by 2 into z minus 1 by 6, z and z inverse get cancelled, plus 1 minus 1 by 2 z. So this to get cancelled, and the denominator will be 1 minus 1 by 2 z and 1 minus 1 by 3 z inverse. Now if you take the LCM for this one in the numerator, you will get 6 minus 1, that is 5 by 6 divided by 1 minus 1 by 2 z and 1 minus 1 by 3 z inverse. You can stop here or you can go with further simplification of this. So this is sufficient, I guess. Now if you look at the ROC, so in equation 1, so 1 by 2 z less than 1 and 1 by 3 z inverse less than 1 must converge. So therefore 1 by 2 z less than 1, so that is 1 by 2 less than 1 by z, so that is z is less than 2. So here 1 by 3 z inverse is less than 1, So 1 by 3 than z. So if you look at this, z is greater than 1 by 3 and less than 2. So combining this, we can write the ROC as lies between 1 by 3 and 2. So ROC lies between 1 by 3 and 2. So that is the uh, location of ROC. Coming to the second one, it says x2 of n is equal to x1 of n plus 4. That means it is the time shifted version of x1 of 4. You can apply the time shifting property. So that is using time shifting property. So time shifting property says if you have x of n minus n naught, if you perform z transform for this, you will get z to the power of n naught into x of z. In this case, we have x1 of n minus n naught. So that means z to the power of minus n naught into x1 of z. So therefore, x2 of z is equal to z to the power of minus n naught into x1 of z. Now in place of n naught, we have minus 4. So that gives us z to the power of minus 4. And what is x1 of z? 5 by 6 divided by 1 minus 1 by 2 z into 1 minus 1 by 3 z inverse. Now you can simplify that like z to the power of 4 into 5 by 6 divided by 1 minus 1 by 2 z and 1 minus 1 by 3 z inverse. So this is x2 of z. Now coming to the sketch part, in the z plane, so you have two circles, one with the radius of 1 by 3, another one with the radius of 1 by 2. So this is the first circle with radius 1 by 3, and this one is 2, and this one is 1 by 3 radius here. Now the ROC lies between these two circles, that is inside the circle 2 and outside the circle with radius 1 by 3. So just mention this ROC. So since no poles and zeros has been asked, we are not going to locate that. So this is how we plot the ROC for this one. Okay. Now I'll take one more example for this one. So given, find the Z transform of x of n is equal to 1 by 2 to the power of n into u of n convolved with 1 by 3 to the power of n into u of n using the properties of Z transform. So given x of n is equal to 1 by 2 to the power of n into u of n convolved with 1 by 3 to the power of n into u of n. Now the property it resembles is convolution property. So let's take that one. From convolution property, we have x of n convolved with y of n should give x of z into y of z. Now here we don't have that, we have x of n. So let's rename this into this form. It is x1 of n convolved with x2 of n should give us x1 of z into x2 of z. So therefore what is x1 of n? So I'll take the first term as x1 of n, that is 1 by 2n into u of n, and x2 of n will be the second term, that is 1 by 3n into u of n. So let's solve for this. So x1 of z is equal to summation n equals minus infinity to plus infinity x1 of n z to the power of minus n. So what we are trying to do is we are going to find x1 of z and x2 of z, and we are just multiplying those two. So that will give you the z transform of x of n in frequency domain. So that gives n is equal to minus infinity to plus infinity. X of n is 1 by 2 to the power of n into u of n z to the power of minus n. Now u of n exists for values of n which are greater than or equal to 0. So therefore the limit will be from 0 to infinity 1 by 2 to the power of n z to the power of minus n. Now if you combine this, you will get 1 by 2 z inverse to the power of n. So that gives us is a standard geometric form. N is equal to 0 to infinity a to the power of n, it is 1 divided by 1 minus a. So based on that we can write this as 1 divided by 1 minus 2 z inverse. And what about ROC, where 1 by 2 z inverse is less than 1, so which will give that as 1 by 2 is less than z. So x2 of z is equal to summation x2 of n z to the power of minus n. So that will give us n is equal to minus infinity to plus infinity. x2 of n is 1 by 3 to the power of n into u of n z to the power of minus n. So u of n is present for values of n which are greater than or equal to 0. So that's why the limit will be n is equal to 0 to infinity 1 by 3 z inverse to the power of n. This is my x of z. So again we are applying the same geometric series, which will give us 1 minus 1 by 3 z inverse, where 1 by 3 z inverse is less than 1. It is now based on this, coming to the final one, x of z is nothing but x1 of z into x2 of z. So that will leave us with 1 divided by 1 minus 1 by 2 z inverse into 1 divided by 1 minus 1 by 3 z inverse. And what about the ROC? So this ROC, if you look at this first term, says z is greater than 1 by 3 and 1 by 2, and second one says z is greater than 1 by 3. So among these two values, 1 by 2 and 1 by 3, 1 by 2 is greater, because if z is greater than 1 by 3, obviously 1 by 3 is less than 1 by 2. So that means if z is greater than 1 by 2, we can say that it is by default it is greater than 1 by 3 as well. So based on that, we can say that z is greater than 1 by 2. So this is the ROC for this. And I hope you have understood these methods. So try some more examples on properties of Z transform. That means use applying the properties, try to get the result. So these are the different types I tried here. Hope you have understood. If you have any queries, do comment on this video. You can reply to me. Okay. Thank you for your time.